fast. Today we are trying to get people ready for their mock AP tomorrow. So we're going to go over a practice exam like we did with you guys finishing up 2008 the day before your mock AP. Tomorrow we're going to have our forever quiz, which is super important to have those down anyway. But some of you, I think the extra night could be very beneficial in many ways. But remember how I said that before spring break we were doing like a quick, let's just get it practice AP in where it goes through all the different topics and it's all mixed up. But after spring break, do you remember what I said we were going to do? Take time to go through each concept. Some of you guys, after doing the 2008, after taking the mock AP, and after doing the 2003, you're like, I think I can see where my weaknesses are. So then we're going to go through topics, the big topics of calculus, not just the big like limits, derivatives, integrals, but you guys saw me with those packets that I was like, hey, look at the 27 essentials, but a packet for each concept. And we're going to try to find those weaknesses and work on them. Does that make sense? The conceptual weaknesses, the what is the AP going to ask me weaknesses, the how are they going to take away points on my FRQ weaknesses, et cetera, et cetera, et cetera. So that's where we're going. But because we have those people doing the mock AP tomorrow, we're going to do one more. And you guys have the bonus exam. Hopefully you did over break because it's 4 free points in your test quiz category if you did. And just because we're going over questions today and I'm collecting stuff anyways, if you have it ready to go, you want to turn it in today, that's totally fine. If you want that extra credit in by the end of the grading period, whatever you do have done, but if you want to try and bust it out tonight and bring it tomorrow, I'll still take it tomorrow. Maybe not for the end of the grading period, so you can do the FRQs, etc. But it will get in your grade. So it's up to you whether you turn it in today or tomorrow, but just like the forever quoting, I'll take it today or tomorrow. Sound good? Okay. And today you can do it by the end of the day. And I'll just grab my piles and work on grades tonight like I already need to do. Okay, so in the 2003, I'm just going to pull up, let me pull up 2 things. But first, just in case you're curious, some of you guys were gone on Friday and didn't get to watch us do this with the 2008 unless you watched the video. This is the scoring worksheet for the 2003. Somebody asked me in another class, like, hey, I think it was Joe Tan, hey, there were some changes in grading. I'm like, yeah, I know. This worksheet was given in order to reflect those changes. So this was not the exact way it was scored in 2003. Way back when, it was actually like, hey, any multiple choice you got wrong, you got docked 1/4 point. It was the old way of doing the SATs and the AP exams. This worksheet was made in order to reflect, and the curving was changed in order to reflect what kind of ended up happening as far as the new ways of scoring. So it's as accurate as the AP College Board can make it, if that makes sense. So if you want to see how you did that in 2003, once again, you would count up how many multiple choice you got right. For your own purposes, you can look at calculator versus non-calculator, which one you're stronger or weaker on. Some of you are like, we haven't used our calculator so much this year, I'm actually bad at it. We need to work on that, right? Some of you are like, no, I'm so good at my calculator, so I need to make sure I'm not using it because I'm really weak on the non-calculator. But that's for your own purposes, what percentage you got right on calculator versus non-calculator. For here, you just need to figure out how many multiple choice you got right, multiply by 1.2. That's how many points out of 54 you got for multiple choice. And then how many points out of 54 you got on FRQs based on how many out of 9, add it all up. They're all just worth 1. I don't know why they do that every year, but they do. Just in case I think they throw out a part, then they could round it or they could curve it appropriately. And then you can add the 2 together and figure out where you were within the 1, 2, 3, 4, or 5. Now guys, if you notice really quickly, which are the 2 biggest categories as far as point spreads? Not 3. The biggest point spreads are 1s and 5s, right? The biggest point spreads are 1s and 5s. Does it take work to get out of the 1 range? Yeah, you need 22 points, which means you need, depending on if you were to split that half and half, you need 11 points out of FRQs, which is more than 1 per 1. It's more like 2 per 1. Maybe stronger in some, weaker in others. And then up here, if you were to go for 11 points, you would need like what? 10-ish, 9-ish questions, 10 questions, because it doesn't round up in any way, shape, or form. So it takes a little bit of work to get out of the 1 range, but once you get out of the 1 range, the point spread, check it, see? The point spread goes from 22 to being 11 to being 15 to being 17, and then of course you have your super crazy high 5 range. But guys, to get into the 5 range, 69 out of 108, is that a great percentage? So that's why I say we're aiming for like a 65, a 70%, somewhere in there, because that's always where the 5 is going to hit. So you do not need to be perfect, but do you need to be able to get multiple choice right? Yes, and not be tricked. Do you need to be able to show what you know on an FRQ and not have them take away your points? Do you guys know what what BCers and I were doing the Sunday after your mock AP at Maggie Corey's house? Grading your FRQs. Do you know what was happening? A lot of sadness, because people weren't writing DXs or DYs. So points they even did get got taken away. Now there were other things, like, don't they know that to take a limit to 0, you actually go to 0 and you don't go somewhere else? I don't know, a lot of people were talking about 6 when you weren't supposed to be there. Anyway, there were a few different things like that, especially the one-sided limits. That was really sad, but it's okay, because the BCers were like, oh, we had that one and we didn't do so well on that one either. Like, there were some tricky things on the FRQs that they had to figure out. But there were also times where like, oh, they just made it wrong. Oh, they should have known. Like, there was a lot of that. Now, they're going to make you videos about how to do the FRQs so that when you get your practice APs back next Monday, you won't just have it graded with a score of 1, 2, 3, 4, 5, the mock ones, the makeup ones and the original ones. You will also get copies of the exam you didn't take so that you can work on the other one as a bonus practice exam. So the people who take it Wednesday, you'll get a copy of the other one. So when we go over corrections, you can refer to it. The people who take it on, did I just do it backwards, Saturday and didn't take it on Wednesday, you'll get a copy of theirs so you can go over that. But you also have the BC videos explaining step by step the FRQs, what the directions were saying, what they were asking for, what you guys did wrong, thought wrong, answered wrong, made wrong, etc., etc., etc. But you need to not only be able to get multiple choice right and avoid the tricky ones that are just screaming for you to pick them, but also get FRQ points and not lose them. Anyway, all that to say, I just wanted to quickly walk through the score sheet, because some of you totally ignored that on your 2003, and that would be a good thing as far as you guys analyzing how you did on that mock AP, or that practice AP, sorry, I should say. But now I want to get into the actual questions themselves. So I'm opening up really quickly the multiple choice with the answer key, because we don't have time for me to solve through every single possible question that you could have, but I can talk through each of the different questions that you have. So let's start with multiple choice. Is there anything that you guys have been like, I don't know why or how? Any of the multiple choice that you guys marked wrong or had corrections on? Rachel? 19. We'll just go in whatever order, guys. When you find one that you have a question on, just let me know. Number 19. Remember, if you didn't do it, you can go in the back of your homework spiral and be playing with these ones. Not a bad idea. Number 19 is in the non-calculator section. Something to keep in mind. And then the directions say a curve has a slope. Oh, I love these translating ones. A curve has a slope. As soon as it says slope, what should you be thinking of? Derivative. Good. So as soon as you hear slope, you should be thinking of derivative. Let's see, it went to the right place. The name of the game for some of these is just good old-fashioned translating. So a curve has a slope. I could say right away, dy dx is equal to 2x plus 3. At each point xy on the curve, okay, yeah, derivative function gives slopes at every point. Okay. Which of the following is an equation for this curve? I know it's giving it to you in words, but what is it saying? An equation for the curve. The curve is the function an equation for the function, y equals f of x. If it passes through the point 1, 2. Why am I changing to blue whenever I have 1, 2? Isn't that just a clue? If we have a derivative and we need a function, what do we need to do? Oh no! If we have a derivative and we need a function, if we have a differential equation and we need to solve it, integrate, antiderive. But we can't antiderive until what am I doing right now? Separating. This was what Thomas and Nick, you came in, we were doing the whiteboards. This is what we were doing. Separating, moving the dx to the other side. Because I think you guys both missed this test. And we have to antiderive. The integral of 1 is just y. The integral of, isn't that x squared plus 3x? But what do we do every time we antiderive? plus c. So how on earth do we finish it off? Plug and chug. So we can plug in x and plug in y. So 2 is equal to 1 squared plus 3 times 1 plus c. If I subtract 4, doesn't c equal negative 2? We don't even have to make it look pretty. In a multiple choice, we're just trying to make it match and make it match appropriately. So making it match appropriately, there's only one that has x squared plus 3x and a minus 2. Dun, 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 dun. Watch out for the word slope derivative. Slope derivative. Unless it says slope of the secant, then we're doing f of b minus f of a over b minus a, or average slope. Okay, what else? On multiple choice. If nothing else, give me one that you got wrong. 22. Still in the non-calculator section, right? Number 22 gives us, a graph of who, guys? F prime. Do you see it? The graph is labeled F prime. The directions actually are trying to help you also and say the derivative of F. Keep on hitting the wrong buttons. The graph of F prime, the derivative of F. They could have also, if they were being sneaky, they could have said this is a velocity graph and this is a position clue. They could also do that. They could also throw in an accumulator function. But here's the long story short. They give you a graph of F prime, and they give you clues dealing with who? The clue isn't an F prime. What is it? Okay, so what forever card puts together an F prime with an F of B and an F of A? What forever card puts together F prime with an F of B and an F of A? There is MVT that says F prime of C is equal to F of B minus F of A over B minus A, but we would need to know everybody there. Since we don't know everybody, we're going to get stuck on that one. But what allows us to go from a derivative backwards? Yeah, you could say two different theorems. You could say FTC, that says, hey, if I know A and B, I can go from an F prime to an F, antiderivative of B minus antiderivative of A. It would be capital F, but they gave us an F prime, so we can say normal F. But what's that snazzy formula that says, oh, I'll let you just jump to what you want? Because all you need is to start from where you were. Yeah, you seeing it now? And figure out the change. Isn't this just the same as that? But we give this one a snazzy name. And the snazzy name for this one is integration as net change. If I need to jump to a value, I need to know where it started and I need to know the derivative. So if I want to find f of 1, I'm like, sweet. What's f of 0? 5 plus. How do I figure out what changed from 0 to 1? I look at the area under the curve, because an integral is area, right? So what's the area of this little triangle with a base of 1 and a height of 6? Isn't it going to be 1/2 base times height? 1/2 of 6 is 3, and 3 plus 5 is? The document I didn't want open. 8. Dun, 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 dun. So when they say position is area under curve plus initial position, they're talking about velocity and position and like a final position. I would have just said integration is net change. To find f of 1, I start at f of 0 and I say, sweet, how did it change? What's the integral from 0 to 1, which is area? Dun, 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 dun. What else on multiple choice? 77. We're going to the calculator section as soon as I heard the 70s. Thanks, David, for having that ready. Number 77, let me scroll with the mouse. It'll be quicker. Gives us a graph of f. Well, this should be easy, shouldn't it? It depends on how they ask it. The regions A, B, and C in the figure above are bounded by the graph of f and the x-axis. If the area of each region is 2, well, that's weird. They told us this was 2. They told us this is 2, and that's 2. What is the value of negative 3 to 3 of f of x plus 1? Well, hold on. Plus 1, he's not plus 1. Do we have to like shift this guy and figure out life? How do we integrate, guys? If there's a plus or a minus, what are we allowed to do? Separate. Can't we do the integral of 1 separately from the integral of f? You weren't bound to having to figure that out. You could just separate them. And this one we're going to have to totally use our graph for. But this one, can't we just solve this by hand? What's the antiderivative of 1? X. Can't we do x from negative 3 to 3, right? So that would be 3 minus negative 3 if we do f of b minus f of a. Now how am I going to do this one? Well, hold on. An integral, a definite integral from a to b. Didn't we just talk about how that's area? Okay, so area. If I'm going from left to right, normal direction, how do I count this 2 as a positive or a negative? As a negative, it's below. So we're going to have to do negative 2 plus 2 minus 2. What's negative 2 minus 2? Area above is positive, area below is negative as you go from left to right. Those are going to cancel. I'm going to end up with negative 2 plus 3 minus negative 3 is 6. I think my final answer should be 3. 4? What did I do wrong? Oh, I just randomly wrote it as a negative 3. Issues. Siento. That's rough. To know all the calculus and then do something silly like writing a number wrong. It happens. Anything else in the 20s and the 70s and the 80s, the 90s? '88. Wonder if they put hard ones on all the like 77, 88, 22. All right, this one I'm not going to take a picture of because this one you kind of just have to look at all the answer choices. Sometimes you kind of have to work backwards. Let's see what's going on. Closed interval, 2 to 4. Which of the following could be the graph of f with the property that? So far they're just saying make it match. And it's like, okay, make what match? 1 over 4 minus 2, the integral from 2 to 4 of f of t dt is equal to 1. Does this look familiar at all? Average value, yeah. Average value, 1 over b minus a. The integral from a to b of f of x dx. So the average value is 1. So if the, I need to be able to see my whole graph. Hold on. There we go. So if, is it not going to work now? I thought he fixed it. Nope, he didn't fix it. Okay, E for effort. If the average value is 1, that means that the average y value is 1. I need to orient my board, don't I? Go away, little thingamabob. Here. So the average f is 1. There are a few different ways of looking at it. One is the average f is 1. The other way of looking at it is they actually just said 1/2 times the area because the definite integral is the area. That's what they're writing. So 1 over 4 minus 2 is 1/2. 1/2 the area is 1. So either one of these might be able to help us. Okay. Another way of looking at this, couldn't we say then if 1/2 the area is 1, doesn't that mean that the area should be 2? Right? Okay, let's see. The area of this guy, wouldn't this guy be base of 2, height of 2? The rectangle would have an area of 4, right? So then this compared to 4, I don't think this is half of 4, right? What about this one? This one, 2 times 2, the rectangle is 4. That one could be almost 2, but wouldn't it be a little bit off, guys, because of the curvature, right? So the area under would be a little bit less than 2. That one's going to be way more than 2. This one's going to be less than 2. Well, so far, way more than 2, no way. That one, way less than 2. I'm not so sure about that. This one, if I was to take it, wouldn't that be 1/2 1 times 2, which is that's a 1 and that's a 1? Wait, that one would be 2, wouldn't it? This one, if I was to find the area, 1/2 base times height 1, which would be 1 plus height 2, which is 2. 3 and 2 is 6, 6 and 2 is 3. That doesn't work. That one's less than 2. That one doesn't work. And this one, from 2 to 4, oh, that is 4. The only one that even has the right area is C, and we didn't even have to think about this whole idea of the average value being 1. Sometimes even though you see something that connects to a forever card, it doesn't really help you in any way, shape, or form. It was way easier to think about, well, the area had to be 2 in order for this to be true. And the only one that actually had an area of 2 is this guy. Everybody else is either too high, too low, well, too high or too high. But yeah, good question. Because I totally would have thought the average value was super necessary, but it wasn't even really helpful in any way, shape, or form. Anything else you guys came up against in the multiple choice? Which one? 78. Okay, we're going to go peek at FRQs next. This is our last multiple choice question for now anyway. Doesn't mean you can't pop by after school or something, but for now. So you can be peeking at the FRQs if you want to see if there's anything in particular you want to ask about. 78, I see radius increasing at a rate. Related rates. Radius increasing at a rate. D box dt. D who dt for the first part? What equals 0.2 meters per second? dr dt. The radius is increasing at a rate of, increasing means positive. What is the rate of increase in the area? D who dt? dA dt, such that c equals 20 pi. Isn't circumference of a circle 2 pi r? So couldn't I divide, so it's going to be when r is equal to 10? Well, wait a minute, don't I need to have some sort of formula to actually put all this together? And don't I need the derivative of said formula? But don't forget your r prime. When I take the derivative, the pi is just a constant, bring down the 2, so 2 pi r times r prime, dr dt. Now I can go ahead and do a simple, now that I've thought about circumference and radius, plug and chug of 2 times pi times my radius times my, oh, phew, it's a calculator problem. It wouldn't have been too bad if it wasn't, because isn't 0.2 1/5? So you should have ended up with 4 pi, unless they were all snazzy and decided to do decimals instead. And why is it meters squared per second? Because it's an area measurement and then a time measurement, dA dt. All right, guys, in the FRQs, we still have about 5 minutes. In the FRQs, is there anything in particular? I have the answer guidelines we can just look at wherever you guys want to look at. The first one was an area volume one. Right away, I knew it just by looking at it. Area volume, you were allowed to use your calculator, and you should have used it to its fullest extent. Number 2 was going to be a position, a motion one, with velocity acceleration. Once again, using your calculator for things like derivatives and like integrals, which is why you don't see any work here for the derivative. You don't see any work here for the integral. They're using their calculator. Old school, remember, number 3 was also able to be a calculator. This one was a nasty table graph talking about fuel consumption. I wonder if this is an in-out problem. Then we have another possible area, not volume though, having to do with the graph of f prime, increasing, decreasing, possibly concavity, possibly integration as net change. We have some sort of related rates problem with radius and heights and a volume. And then we have a piecewise, which basically just talks about, do you know how to work with continuity, limits, functions, etc. So where do you guys want to go? Do you want to go? We don't have to. But are there any ones, whether or not you tried them, that you knew or you know is a weakness? Rachel? 4D. Number 4 was that non-calculator one. Given a graph of a derivative, which you guys have asked multiple times even just today in our multiple choice. And 4D says find f of. Wait a minute, not f prime of, find f of. It sounds like we're doing a whole integral to original sort of thing. Wait a minute. Didn't we just talk about how to go from f prime to f? What do we have to do? Integrate, good. So if we integrate, well, we want to land on -3. If we're landing on -3, that means it's not where we're starting. We had to start from somewhere else. Guys, is there anything in this problem that tells us where we could start? Where can we start at? 0. I know f of 0, so he could be my initial, and then I go ahead and add. Remember, an integral is just area, especially if you have areas that are triangles and semicircles, etc. So if I want, oh, wait, my bounds are messed up, right, guys? Okay, so I could go from -3 to 0, but what do I have to consider if I flip around stuff? Okay, so I'm going to have to subtract it or make it a negative. I know f of 0 is equal to 3. I need to come up to my graph and say, well, how do I go from -3 to 0? You guys see it's really just two triangles? So I can go ahead and figure out this guy by 1/2 base times height. 1 times 1 is 1 times 1/2. That's a positive 1/2, but what am I going to have to make this area down here? A negative, right? So 2 times 2 will be 4. 1/2 of 4 is 2. So I'm going to have to go ahead and make f of -3. 3 minus 1/2 minus 2. What are you going to do? Simplify or box it? Box it, stick it to the man. You don't need to simplify that and mess it up with fractions, right? But what's different as soon as you have f of 4? I want to land on 4. If I'm landing on 4, where can I start? Well, I guess I could start from him, but wouldn't that have more area to cover? Why not just start at him again? Yeah. What formula am I using again? Integration is net change. Is that a forever card? One you need to have solid like this? Yes. F of 0 once again is 3 plus. Now here's where some of you would have gotten mixed up. Is the semicircle the area? Or is the SAT math the area between the semicircle and the rectangle the area? So couldn't you have done your rectangle, which would have had an area of, oh dear, what is that, 4? 4 times 2. The rectangle has 8. Wouldn't I have to subtract the semicircle? So 8 minus, isn't it a semicircle with a radius of 2? So that would be 1/2 pi 2 squared. So 8 minus 1/2 pi 2 squared. That's the area. Wait a minute, but is the area above or below? So I'm going to have to subtract 8 minus 1/2 pi times 2 squared. What am I doing? I'm subtracting because the area is below. And I'm taking the rectangle and I'm subtracting the semicircle. Dun, 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 dun. Does that make sense? Yeah. All right, kiddos, with that, it's chapel day, so I'm going to let you guys go. Tomorrow, you can turn in your forever quoting and or your 2000.